Hey kids, Mr. Jong here. Today we're going to be going over systems of equations, specifically 3 strategies that we have learned to solve systems of equations. Now, as you see in the subtitle, a system of equations, or when we solve for them, is finding one answer that works for multiple equations. It could be 2 equations, 3 equations, or maybe even more. But for the problems that we're looking for, we're just going to need to solve for 2 equations. The first strategy we're going to use is called the equal values method. The equal values method is used when we have 2 equations that are equal to the same variable. In this case, we have the equation y equals 2x minus 5, and the other equation y equals negative x plus 4. Because both of these equations have a y equals 2 format, we can use this strategy. This strategy involves setting the 2 other halves of these 2 equations equal to each other. Because both of them equal to y, we can say, instead of y equals 2x minus 5, we can say negative x plus 4 is equal to 2x minus 5. So all I did was replace the y variable in both of these equations with the other half of the second equation. And now we can solve like normal. So what I have to do now is I just have to solve for x. Now, what I'm going to do is that I like to add x on both sides. Because it's a negative value, it's really easy just to add. That will eliminate that x on that side, and I'll be left with 3x minus 5. That's all going to be equal to 4, right? That's what's left on that side. Now that I have the x's on the right-hand side, I'm going to go ahead and eliminate that negative 5 with a plus 5 on both sides. That's going to make a 0 pair to cancel out those negative 5 units. And I'll be left with 9 units on the left-hand side, and that'll be equal to positive 3x. And last but not least, because I have 3 x's are equal to 9, I'm going to go ahead and divide that by 3 on both sides. And that's going to give us the answer x is equal to positive 3. Now we're not quite done yet because we have 1/2 of our solution. Now we have to take this x value and we need to use it in one of the original equations. So you can evaluate it into either negative x plus 4 or 2x minus 5. I'm going to go ahead and use it in the negative x plus 4 equation because the numbers are smaller. So I'm going to say y is equal to negative x, which in this case is negative 3, negative positive 3, plus 4. Y is equal to, well, the opposite of positive 3 is just negative 3, plus 4. Y is equal to positive 1. And so my answer is, at the very end, positive 3, positive 1. The second strategy we're going to go ahead and use is called the substitution method. Now, if we take a look at our equation over here, we have x plus y is equal to 12, and x is equal to 3 times y. In this case, it's different than the equal values method because we don't have an x equals something and an x equals something, or a y equals something and a y equals something. Right? In this case, we have x plus y on one side and just an x equals here. But what we can do is something similar. Because I know that x is equal to 3y, I can take this x, or excuse me, this 3y, and I can replace it with the x in the previous equation, otherwise known as substituting. So what I'm going to do is that instead of saying x plus y, I'm going to say, hey, x is equal to 3y. I'm going to write that in and substitute x for that new equal value. And now I have a new equation. And what we have now is that instead of having two different variables, we now have the same variable. And we can solve it now. So 3y plus y, well, that's simply 4y is equal to 12. And now I have 4y is equal to 12. I want to know what just 1y is equal to. So I'm going to divide by 4 on both sides. 4y divided into 4 groups is equal to 1y per group. And that 1y per group is going to have 3 units in each of them. So we know y is equal to 3 now. And just like the equal values method, we're going to take this 3 and we're going to evaluate it back into one of the previous equations. It could be x is equal to 3 times y, or x plus y is equal to 12. Now again, you can choose either, but I prefer using the one with the smallest numbers, or the least amount of work. So in this case, I'm going to take this this y equals to 3, and we're going to replace it here into this y. So I'm going to take the second equation, x is equal to 3 times y. And now that I know how much 3 is, I can evaluate that back into this equation. So x is equal to 3 times, instead of y, we know y is equal to 3. So I'm going to replace that and you substitute it back into the equation. And now I can solve for x. And thus x is equal to 3 times 3, which is simply 9. And so for this equation, the answer is 9, 3. Now, the final solution, or the final strategy rather, is called the elimination method. So let's take a look at this. I have two equations here. 9x plus 7y is equal to 4, and 9x minus 3y is equal to negative 6. Notice how these two equations are written in standard form. ax plus by is equal to c. This means that we cannot use the equal values method, because equal values method needs to have your equations both in the same format, y equals mx plus b. And we cannot use the substitution method because none of these are written in terms of y or x. And so we have to use the final strategy known as elimination method. And what elimination method is searching for is, okay, looking at my two variables here, I have x's and y's. X's and y's. And what I want to do is that I want to combine these two equations in such a way that I can create 0 pairs and just enough 0 pairs to fully eliminate either my x's or my y's. And in this case, if we take a look, we have the same amount of x tiles here, 9x and 9x. Now, in this, at this point, right, we have to think to ourselves, okay, I have the same amount of tiles. Do I need to add these tiles together to fully eliminate them, or do I need to subtract them? So because we both have the same sign, or they're both positive, we're going to need to subtract them. And what subtraction means is that I need to convert one of these, I need to convert probably my second equation into the opposite form, meaning I need to reverse all of the signs by subtracting the bottom equation from the top equation. So when I subtract, instead of just combining all of our terms, combining our terms straight, we're going to distribute this negative sign, like so, into each of these terms on the inside, reversing the sign. So instead of right? Instead of having 9x minus 3y equals negative 6, if I switch the side through subtraction, we're going to get this instead. Positive 9x is going to become negative 9x. Negative 3y will become positive 3y. And negative 6 is going to become positive 6. And again, the reason why we can do this is because I am changing everything by the same amount, right? By multiplying it by negative 1. I cannot just pick and choose one term over the other. I have to do it to everything. And now that I have subtracted or reversed the sign, I can now combine it like normal. So 9x and negative 9x, that becomes our zero pair, and we've eliminated that. And thus, underneath, we are left with 7y plus 3y becomes 10y equals to 4 plus 6, which is 10. And now we can solve this pretty normally. 10y equals to 10. I want to know how much 1y is. So I'm going to divide my 10 y's into 10 groups to get 1 y in each group. And I'm going to take those 10 units and distribute them into the 10 groups as well to get y is equal to 1. Now, just like our two other strategies, equal values and substitution method, now that we got the solution to one of our values, we're going to substitute this back to our original equation. So it could either be this equation up top, 9x plus 7y equals to 4, or it could be our bottom equation, negative 9x plus 3y is equal to 6. Now, I don't know about you, but I would rather work with just positive numbers, so I'm going to evaluate it into the top equation, because that just has positive numbers, and those are easier to work with. So I'm going to go ahead and take that equation, 9x plus 7y equals to 4. And now that I know how much y is equal to, I can evaluate that for the y variable. So 9x, still don't know what x is, plus 7 times 1 is equal to positive 4. And now we can solve for x, because now we just have one variable in this equation. 7 times 1 is positive 7. And I'm going to bring down everything else of the equation, right? Because I've only simplified one part. And now I got 9x plus 7 is equal to 4. I want to get to that x, so I got to undo this positive 7 by subtracting it. Plus 7 minus 7 is equal to 0, right? This is a zero pair. And so we are left with 4 minus 7, which is equal to negative 3, is equal to 9x. Now I have 9 x's, and they are equal to negative 3 units. So I need to divide my x's into 9 equal groups to get 1 x in each group. And I have to take that negative 3 divided into 9 groups. And if you could probably tell, this isn't going to be a whole number. And so what I'm going to do is I'm going to try to simplify this fraction. So I need to think to myself, okay, I want to make this fraction as small as possible. So what number can I divide the numerator and denominator by that will make it a smaller number? It's got to be the same number though, right? And so in this case, the greatest common factor of 3 and 9 is 3. It's the biggest number I could divide both of these by and still get a whole number. So negative 3 divided by positive 3 is negative 1. And 9 divided by 3 is 3. And so what I'm saying is that this fraction, negative 1/3, is the same fraction as negative 3 over 9, just using smaller groups, smaller numbers. And so x is equal to negative 1/3. 3. And so what I got to do now is combine my x and y value into a solution. So negative 1/3 and positive 1 is the solution for both of these equations. All right, so let's summarize what we just did. So, as a reminder, systems of equations is all about finding one answer that solves multiple equations. With the equal values method, we had two equations that were both set to the same value. And we could take both of those halves, stick them together into one equation, and solve. Substitution, on the other hand, says if I have at least one equation that's solved for the variable, so I can have an x equals or a y equals, I can use substitution to evaluate that second equation back into the first. An elimination method is used when we have two equations in standard form, and we need to find a way to create a zero pair with either our x values, y values, or whatever variables that we end up having. I hope this helps give you a brief overview of the systems of equations and the three strategies we can use to solve for them. I hope that helps. Take care, everyone.